thought process for 16.1 double integrals. So the first integral I see here, so immediately when I see this, I think we will need to integrate the function y squared plus y with respect to x first, and then with respect to y. So I'm going to go ahead and start with integrating with respect to x first. So y squared plus y is independent of x, so it can be treated as a constant during the integration with respect to x. And so that's how I landed with 1 right there. So now let's integrate with respect to y. That does not look like a very good y. So this can be split into two integrals. So let's go ahead and just do these separately. So for the top one, did I write this correctly? Yeah. Y cubed over 3, we're valuing from 3 to 1. So it's going to be 3 cubed over 3 minus 1 cubed over 3. And that's going to be 27 over 3 minus 1 over 3. Which is equal to 9 minus 1 over 3. I don't know what that is. I'm just going to use my calculator. It takes a second for my calculator to turn on, so I'm just waiting for that right now. That's so depressing that my calculator takes some time to actually turn on. Okay, well in the meantime, we can start the bottom one. So this is just going to be y squared over 2, and we're evaluating from 1 to 3, and this is going to be 3 squared over 2 minus 1 squared over 2. And my calculator is still loading in. I wonder if it's actually dead right now, which is not ideal. It's not dead, it's at 100%. It was just in deep sleep mode. Okay, so 3 cubed over 3 minus 1 cubed over 3 is going to equal 26 over 3. I have no idea if all of this is like actual correct mental math, but hopefully it is. So 3 squared over 2 minus 1 squared over 2, that's just equal to 4. I could have easily just done that in my head. I don't know why I just went automatic for that. So now as a result, we're going to do 26 over 3 plus 4. So 26 over 3 plus 4 is equal to 38 over 3. I think that's my final answer. Let's write that bigger. So there's my thought process for the first integral. So the second integral, let's go ahead and set up the integral first. We're integrating from 1 to 4, 0 to 3. That's x plus 2y dx d. That does not look like a y. And so let's first integrate with respect to x. So we're integrating from 0 to 3 of x plus 2y dx. And so now we have to integrate each term separately. Do I have to write that out? Do I have to write that out? Okay. So I want to make sure that I don't run out of, okay, I'll be fine on the vertical room, hopefully. But just because I'm going to go ahead and write horizontally, which I don't really like doing. So that's going to be 3 squared over 2 equals to 9 over 2. And then the second integral, 2y 0 to 3 is equal to 2y. 3 minus 0 is equal to 6y. So it's going to be 9 over 2 plus 6y. So now let's integrate with respect to y. So we're going to have the integral of 1 to 4 of 9 over 2 plus 6y dy. And again, we have to separate the terms, so we're going to have integral of 1 to 4 of 9 over 2 dy plus the integral from 1 to 4 of 6y dy. So let's go ahead and take a look at the first integral, which is going to be the integral of 1 to 4 of 9 over 2 dy, and that's just going to be 9 over 2y. 1 is equal to 9 over 2. 4 minus 1 is equal to 27 over 2. And now let's take a look at the second integral. We're integrating from 1 to 4 of 6y dy is equal to 6 y squared over 2, valuing from 1 to 4 is equal to 6 times 4 squared over 2 minus 1 squared over 2. That's going to be 6. 4 squared. Oh, that is not what I meant to press. Which is going to equal to 45. And as a result of those two integrals, hold on. Yeah, we're going to have 27 over 2 plus 45, which is 117 over 2. Wow, this thing is really laggy right now. It seems to be working fine. Oh well. Alright. This one. So to get to what I'm thinking right now, I'm thinking a little bit ahead. Let's go ahead and just start with writing out the double integral. So we need to integrate with respect to x. So to integrate this, we could use u sub, where u is equal to x cubed times y, and then du would be 3x squared times y dx, or dx is equal to du divided by 3x squared times y. But integrating with respect to x is simpler if we look at the inner as a derivative. We know that x cubed times y as the exponent, so we could take its derivative, which is, hold on, okay, cool. I'm not crazy. Kind of, sometimes. 2x 5x cubed y times 3dx. This is not very aligned. Yeah, and that's pretty straightforward. Okay, now we need to integrate with respect to x. or sorry, with respect to y. And now we distribute the double integral. And now we have to integrate each of them separately. So let's go ahead and take a look at that first integral, which is 2 times the integral bounded from 0 to 2 of e to the 8y dy. And that's going to be 2e to the 8y over 8 to 2 e to the 16 over 8 minus 1 over 8, which is equal to it's going to be e to the 16 minus 1 all over 4. And then that's literally just the same. We can write that to be 1/4 e to the 16 minus 1. And then let's take a look at that second integral, which is not write that equal sign. And now if we combine those results, we should be getting 1/4 e to the 16, why did I write that? Minus 1 minus 4. Let me write that 4 better. So that's my thought process for all of this. And I guess we can also do it with U-sub, but I'm kind of lazy. So that's my walkthrough for 16.1.